All right, before we even get started today, I want to pose a quick question to you. Think about every single new road, every massive bridge spanning a river, every towering skyscraper, and every complex water system keeping millions of people alive around the globe. By the year 2040, what do you think the sheer financial scale of global infrastructure demand is actually going to be? Just take a second. Got a number in your head?
Well, brace yourself. The estimated global investment needed by 2040 is a staggering $94 trillion. And yeah, that is trillion with a T. This absolutely massive figure shows us just how critical the construction and infrastructure industry is to our survival. And the professionals standing at the very front of this monumental world-shaping investment? Civil engineers.
Okay, let's dive into this. Welcome to today's explainer, Civil Engineering, building the infrastructure that shapes our world. We are going to provide a completely honest, no-holds-barred guide to this fundamental field. We're stepping way beyond the textbook today to uncover the realities, the actual paychecks, the dirt on the job site, and the cutting-edge tech that's literally transforming how we build our world. So here is our roadmap for the day. First, the blueprint. Then the foundation, followed by the framework, smart systems, and finally, our final inspection. Let's get to work.
Phase 1, the blueprint. What exactly is civil engineering?
Technically speaking, civil engineering is the professional discipline dealing with the design, construction, and maintenance of the physical and naturally built environment. But you know what's really fascinating here? It's the sheer permanence of that definition. Unlike a piece of software that gets an update every couple of weeks, professionals in this field create tangible, physical works that last for generations. We're talking about a permanent legacy that stretches all the way from the ancient Roman aqueducts to the ultra-modern skyscrapers of today. Civil engineers are quite literally the architects of human civilization. And it's a massive umbrella. In fact, civil engineers are involved in over 90% of the world's infrastructure projects. It's kind of like a giant puzzle with 5 main pieces. You have structural engineers making sure buildings and bridges don't collapse, transportation engineers designing highways and transit systems to fix your daily commute, geotechnical engineers studying the dirt to make sure foundations actually hold, water resources engineers managing dams and water supplies, and environmental engineers focusing on sustainable practices and waste management. You could literally be designing a 100-story skyscraper one year and a wastewater treatment plant the next.
Moving on to phase 2, the foundation. Let's talk education and skills.
So, what does the actual university journey look like? Well, this timeline maps it out perfectly. Year 1 is your basic engineering foundation, heavy on the calculus, physics, and programming. But year 2, that is where it gets real. You start surveying actual land and learning fluid mechanics. By year 3, you're doing a serious deep dive into core concepts like structural analysis and soil mechanics. This is the fun part where you get into the lab and literally crush concrete cubes under 400 kilonewtons of force just to see exactly when they snap. Finally, year 4 is all about advanced tech, specialized electives, and bringing it all together in a massive capstone project. And this brilliantly illustrates the real-world toolkit you walk away with. These aren't just high-level academic theories. These are highly valued practical skills that employers are actively hunting for. You'll master structural analysis, using top-tier software to calculate loads. You'll become proficient in CAD and BIM modeling to build intelligent 3D replicas. You'll learn the ins and outs of geotechnical investigation, tight site management, and precise surveying. Ultimately, employers want you because you know how to safely turn a complex mathematical theory into a physical, standing reality. All right, phase 3, the framework. Let's get into the gritty job site, the specific roles, and yes, the salaries. We absolutely have to contrast the shiny, air-conditioned design office with the reality of the actual job site. If you're a site engineer, your day starts early. By 7 a.m., you're in a hard hat giving a safety brief and walking the site. Midday is spent obsessing over concrete curing times and coordinating with various contractors. The afternoon, that is all about rapid-fire problem solving, like figuring out on the fly what to do when a massive structural beam clashes with an AC duct on the blueprints. By evening, you're wrapping up and submitting progress reports. It's dusty, it's exhausting, and it demands incredible engineering judgment on your feet. Okay, let's talk numbers with from radical honesty. Starting salaries for fresh graduates in places like India might lag a bit behind those massive tech sector packages, typically ranging from 3 to 10 lakhs per annum. But look at the international market. The long-term earning potential is staggering, especially in the Middle East. Gulf countries are experiencing a constant construction boom, offering starting packages of $45,000 to $65,000. And the best part? That is completely tax-free and often includes your accommodation. And the career ladder here is super clear and meritocratic. You put in your time in the dirt for the first 3 years as a junior or site engineer. By years 3 to 7, you are stepping up, managing multiple work fronts as a project engineer. By year 8 and beyond, you're moving into highly lucrative leadership roles like project director or VP of operations, pulling in upward of 50 lakhs per annum in India or well over $150,000 internationally. Your hands-on field experience translates directly into serious, highly paid authority.
Next up, Phase 4, Smart Systems. Let's look at AI, BIM, and future tech.
If you're thinking this field is just old school bricks and mortar, absolutely scratch that. The industry is evolving at breakneck speed. We're talking about building information modeling, or BIM, where brilliant 3D models automatically detect structural clashes months before a shovel even hits the dirt. We've got drones tracking site progress, IoT sensors embedded right into smart highways to monitor stress, and, get this, self-healing concrete that uses dormant bacteria to automatically fill in its own cracks. My biggest takeaway from all the data? Learn BIM tools like Revit immediately during your degree. It's basically mandatory now.
So we've got to talk about the AI elephant in the room. What's the real story? Well, the future isn't AI versus engineers, but engineers with AI versus engineers without AI. It is an absolute game changer. It can optimize structural layouts to save 20% on materials and completely automate those boring, repetitive drawings. But here is the thing. Construction is a highly physical, incredibly safety-critical reality. AI cannot replace the human elements of on-site problem-solving, stakeholder negotiation, and most importantly, ethical accountability for human safety. AI will be your best assistant, but the final judgment call, that's still entirely on you.
And that brings us to Phase 5, Final Inspection. Is civil engineering actually right for you?
Let's weigh the trade-offs fairly here. On the pro side, you have a totally tangible, lasting societal impact and incredible job security. Because, let's face it, the world is always going to need infrastructure. Plus, the global demand is huge. On the reality side, you are likely looking at lower initial starting salaries compared to the IT sector, and the work itself can be physically grueling and sensitive to economic boom and bust cycles. You really have to ask yourself if you want a cushy, climate-controlled desk job, or if you want the profound, unmatched satisfaction of pointing to a massive bridge or a skyline and saying, yeah, I built that.
Which brings us to our final thought. The world desperately needs passionate, dedicated engineers to solve real physical problems. So ask yourself honestly, do you want to build a legacy that society will literally rely on for the next 100 years? If the idea of shaping the physical world around you excites you, then this might just be the absolute perfect blueprint for your career. Thanks so much for joining me for this explainer, and keep staying curious out there.